The time has come to stop talking about all of these little problems we can have with BGP and split horizon and these restrictive rules and start solutioning them. And we're going to do that here with route reflectors, because a router that is configured as a BGP route reflector can take a route learned from an internal peer and advertise it to another internal peer. Now, the peers that send routes to the route reflector are referred to as clients. And when the route reflector gets a route from a client, the reflector does just what you think it would do. It reflects the routes to other clients. Now, the clients have absolutely no idea this is going on. The clients don't know their clients. They don't care that they're clients. And they actually don't require any additional configuration to make this happen. The only config you need for route reflectors is written on the route reflector itself. And what happens here is, with clients having a peering with the route reflector but not with each other, we avoid that entire full mesh mess. Now, a BGP speaker with a peering to a route reflector does not have to be a client. And we have a really clever name for the ones that are not clients. We call them non-clients. Now, they would need a TCP connection to every other router in the AS. And we'll get back to the non-clients a little bit at the end of this lab, but right now we're going to reflect a route or two. And here's the setup. And while we're using the same networks, frame network 172.12.123.0, router 1 with the hub being the hub and 2 and 3 being the spokes, note that the internal peerings are only going from 2 to 1 and from 3 to 1. We do not have a full mesh. Also on the Ethernet network, we're using the number 172.12.234.0, but note that router 2 is not on this segment in this particular lab. So if you want to draw that out, I think that's a great idea, but right now I'm going to go ahead and bring the equipment up. You'll definitely want to be able to track these routes as we go along, or this route, because we really just need one to test it. We're going to start over on router 4, and I already have the peerings in place. You know how to create those. They've been verified. Not throwing you any curveballs here yet. And I also have a loopback on router 4, and we're going to advertise that into BGP right now. Nothing to it, so there it is on router 4. And let me do a quick show IP BGP. And we see a valid and best entry there. Hopefully we would see one here. We see a next hop of all zeros, means it's a locally originated route, or that we're there actually. And the weight is 32.768, which is the default weight of a locally originated route. So far, so good. Let's go one step at a time through the lab and see who else has that path. And router 3 has a valid and best entry for it. You see the next hop of 234.4. We know the next hop rules. We know that makes perfect sense. And we also know that since router 3 has an interface on that network, that reachability is not an issue. We also see the AS path there at the end starting to build. We see now, instead of just an I, we see an I and a 4 in front of it. And we see the weight of 0, which we expect, and we know that's the default. Let's go up to the hub router, router 1. And all is not quite well. But I know you already know what the issue is here, just by looking at this. We've got a network entry. It's valid, but it's not valid in best. And what's the very next entry? Hintity hint hint, going from left to right. The next hop. We know the next hop rules. We know why that next hop is still 234.4. And we know we got to do something about that. Before we even start with the route reflectors, we got to fix this. And of course the problem, if we run show IP BGP with the network number, we'll see that not advertised to any peer. That's interesting, but also inaccessible. And if it's inaccessible, ain't no use in fixing anything else, because we got to fix that first. And we're going to do that, of course, with next hop self. We'll go back to 3, 1, and we want next hop self. Just save on the way out. Not there yet. Give it a few seconds there, being the impatient souls that we are. And there we go. The next hop is changed to 123.3, and since that is certainly reachable by router 1, we no longer have an inaccessibility issue. See, it all becomes second nature. You knew what that was before I even showed it to you. Now let's go over to router 2. And we've already gotten a huge hint as to what we're going to see here, which is nothing. We're not going to see the route at all. It's not just that it's valid but not best, or best but not valid. It just ain't there. And the problem here is, of course, we go back to router 1 and we have a look. Show IP BGP 4444, and you can see right under paths, not advertised to any peer. That's because of BGP split horizon. Doesn't have anything to do with the next hop. That was another issue we had to solve. So we actually had two problems here, and we've already fixed the next hop. Now we're going to fix this one. But let's go a little further here. Let's go a little further. Let's go over to router 2, and we're going to add a loop back and see who gets that. You know, we're going in reverse this time. We're going to put a route on 2 and then go 1, 3, 4 and see who has it and who doesn't. I may already have a loop back on there. Doesn't look good. Okay. And then under BGP, now let's go up to router 1 and have a look. And router 1's got a valid and best entry for that new network, 123.2 next hop. We figured that. And we go over to router 3. And router 3 doesn't have anything for it. Not an inaccessible entry, not a valid but not best entry, nothing. And this is BGP split horizon in action, and this is where we want to put in a route reflector. Because if we put in a logical mesh, or excuse me, a logical connection between 2 and 3 here, would be okay. But then you get into, of course, as the network grows, you know, what happens when you have 10 routers? What happens when you have 20 routers? What happens when you have 100 routers, which you could certainly have in a BGP deployment? You don't want to keep up with all those full meshes. So what you want to do is make router 1 the route reflector, since it is the hub of this particular AS. So let's go over to router 1. And the official long-winded command we need here is route reflector client, which the iOS help tells us nicely that it is to configure a neighbor as a route reflector client. Thank you, Captain Obvious. So let's go ahead and do that. I'm going to type in the entire command, hopefully. Then again, maybe I won't. I need to practice my hyphens. Something might have just happened there that you might not have expected, and you might not see in every book and every piece of documentation you see on BGP. So I want you to see it here, and that is that your adjacency will go down when you configure a route reflector. Now it came right back up, and we can see by our timestamps it took about 15 seconds, I believe. Let's see. I think it's a neat thing about timestamps. So here we are, it went down at 3643, that's router 2. Came back up 3649, so it's just 6 seconds. I misread. And then you can see dot 3 went down at 3650 and came back up at 3659. So if nothing else has changed, your connection should come right back up, but this is definitely something for you to be aware of for real-world networking. So let's see what happened here. And hey, look at that. There's your valid and best entry for network 4 on router 2 that we didn't have before. And you see the next hop was preserved at 123.3, so that's no problem. And if we go over to router 3 now, you can see that the route reflecting in AS123 is working perfectly. And we've got valid and best for network 2 there as well. Pretty cool stuff. Let's go back to router 1. Actually, let's do some first. You tend to run summary, show IP BGP summary, when you're just checking your adjacencies real quick, like before you start a lab, and you see it here and you look under up, down, and it's like, okay, you know, we're up and running. And I understand that. I do the same thing, as you've seen in the videos. Because show IP BGP neighbor just gives you so much information. And a lot of times you don't need this much. But it is a great command to be familiar with the output of, especially right here in the middle when you've got route reflector client. This is how you verify that neighbor is particularly, that particular neighbor is a Route Reflector client. I ran show IP BGP neighbor, so it's going to give me the information on all of them. Pardon the beeping there. And let's see, you can see right here also at the bottom, last reset, and it even tells you due to Route Reflector client configuration change. Pretty sweet stuff. So that's really it for Route Reflector. It's just that simple, and the key is just knowing where to configure it. Let me show you that little bit of information. Everything I'm going by on the screen, we did live and saw that. But I wanted to show you the information about the clients and non-clients, because route reflectors don't just reflect to everyone, mind you. How a route reflector handles a routing update depends on the type of BGP router that actually sent the update. Memorize this list. It'll save you some headaches on your exam and in the real world. Now, when the route reflector gets an update from a client, it's going to send that to all client and non-client peers. When a route reflector receives an update from an external peer, it's going to send that update to all client and non-client peers. All makes sense so far. However, updates from non-client peers are sent to all clients, but not all non-client peers. That's the one you got to watch. Anytime you've got non-client peers in there, that's a bit of a red flag. I better really watch what I'm doing here. And that's the key one to remember, that when a route reflector gets an update from a non-client peer, it's going to send that update to all of its clients, but not other non-client peers. Now, once you have your BGP config in place, and we've done a pretty good job, a really good job up to this point, you may want to fine-tune the routes that you want to advertise. You may want to fine-tune the routes that you don't want advertised. And either way, prefix lists really help, and they're coming up next.